The Rungekutta second order states that K1 and K2 must be determined. Based upon the values of K1 and K2, we will find out the value of Y1. K1 is equal to H into F of X0, Y0. Hello and warm welcome to one and all. It is Dr. Ravikumar YB, Department of Computer Science, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's class, you will be taught about the Rungekutta second order, fourth order and trapezoidal method. Here in this case, we have the initial value problem for this. What is the meaning of this? We have z dash is equal to minus f of minus x comma z. The derivative of z is represented by z dash. Again, we have z of minus x. So, x is a function, y is a function of x. Similarly, x is a function of y, z. In turn, z is a function of the z dash. We have that. So, in this interval, we have minus x0 and minus a, for which minus x0 is the leftmost endpoint, and we have the other values, the approximate values between minus x0 and z. We have the values like z1, z2, so on up to zn. For this, we have a solution. Minus x0 plus h gives me the value of z1. x0 plus 2h will gives me the value of z2. So on up to value of zn. Then we have to find out these values. So if that is the case, we have x0 to z, we have values called z1, z2, z3, so on till zn we have. So that is the interval. If that is the case, let us consider the equation with this, that is y minus 1 whole square into y dash is equal to 2x plus 3. For this, if I simplify this, y dash is equal to 2x plus 3 divided by y minus 1 whole square. This is the y dash. That means f of x is equal to 2x minus plus 3 divided by y minus 1 whole square. What does the Rungekutta second order states? The Rungekutta second order states that K1 and K2 must be determined. Based upon the values of K1 and K2, we will find out the value of Y1. That is, Y1 is equal to Y0 plus K2. If that is the case, what is the value of K2? K2 is equal to H into F of x plus h comma y0 plus K1. What is the value of K1 then? K1 is equal to h into f of x plus h by 2, that is x0 and y0. That is the value of K1. K2 is equal to x plus h by 2 comma y0 plus K1 by 2. That gives me the value of K2. With this K1 and K2, I am deriving the value of y0 and y1. So from this, let me consider this function f of x equal to 2x plus 3. In this case, we have what is the value of x equal to 0? X equal to 0, 0.1, 0.2, so on up to 1 we have here. If that is the case, what is the value of x0 comma y0? That is x0 comma y0 equal to 0 comma y1. We have the 1. The value of 1 is equal to what? 4. That is y0 is equal to 4, x0 is equal to 1. That means y of 0 is equal to 4 we have. See here, the simplified one, that is y of y dash is equal to 2x plus 3 divided by y minus 1 whole square. So if that is the case, we have z dash is equal to 2x minus 3 divided by y minus 1. We have substituted the value of z into in place of y. So z minus 1 whole square, where z of minus 1 equal to 4. It is pretty much clear in this, that is reversing the order like this. If I further simplify that, that is y is equal to 1 plus 3x square plus 9x plus 15 to the power of 1 by 3. If that is the case, the differential equation is separable. This formula can be obtained by the method of dissection. See, observe the values of x0. That is, when the value of x0, we have minus 1 here. What is the value of 0 here? We have 3.466212070. We are ranging from minus 1 -1 to -0.9. That means x0, x1, x2, x3, x4, x5, x6, x7, x8, x9, x10. We have these values. Moving on to this z we have, let me consider this as z0, z1, z2, z3, z4, z5, z6, z7, z8, z9, z10. We have these terms like this. So if that is the case, we have the value, when the value of x0 equal to -1.0, we have found this value, that is 4.00. That is the initial value we have been given. So we have the value x1. We have to find out the value of x1. When the value of x1 equal to -0.9, we have to find out the value of this z, that is y. Moving on in the same manner, we have this equation like this. It is y of -1. -1 is equal to 0. If that is the case, we have z of -1 equal to 4. We have the terms like this. Then we have the initial equations considered here is k1 is equal to h into f of x0 comma y0. K2 is equal to h into f of x0 plus h by 2 comma y0 plus k1 by 2. Then we have y1 is equal to y0 plus k2. This is the formula for Rungekutta second order method. Rungekutta second order method. What is the value of f of x0 comma y0? x0 is equal to -1. What is the value of y0? We have 4 here. This is the value of x0 and y0. Now, if I substitute this into that equation, that is into that function, the function of this is written as this: 2x plus 3 divided by y minus 1 whole square. That is 2x plus 3 divided by y minus 1 whole square. That is this. We have the term, what is the value of x here? -1. 2 into -1 plus 3 divided by y minus 1. That is 4 minus 1 whole square, which is equal to -2 plus 3, that is 1, divided by 4 minus 1, 3. 3 whole square is 9. That is equal to 0.33. If I further simplify this, I'll get point here, that is 0. 9 3s are 27, 3s are 27. This is a recurring. So 0.33 is the value of this. So 0.33 into step size is what? 0.1. H is equal to 0.1. So 0.1 into 0.33. So we have 0.0333. That is the value of K1. That is K1 is equal to this. How can we find out the value of K2? That is K2 is equal to some value which is equal to H. That is 0.1 into f of x0 plus h by 2. What is the value of x0? That is the value of x0 is equal to -1. -1 plus what is the value of h? 0.1 by 2 comma y0 is what? 4. 4 plus k1 by 2. What is the value of k1? That is 0.0333 divided by 2. If I simplify this term, I'll get the value which is equal to 0.05 plus 1 minus 1. That is -1 plus 0.05 comma this term. 4 plus 0.3 means 0.1. That let me divide it by 2. If I divide it by 2, what happens? If I take this towards 2 terms towards this side, I will be adding 200. That is 3.33 divided by 200. This becomes 200. If I further simplify that, I'll get the value which is equal to, that is 2 ones are 2. That is 1. Is equal to 0.015, that is the value, plus 4, that is equal to 0.015, that is the value, that is -1 plus 0.05, that is equal to -1, that is -1, 0.05, which is equal to the value, that is 5, 0 here, point, we have minus 1 here, so that becomes equal to 0 point minus 1 plus 0.05, which is equal to the value 0.95 comma 4.015. Let me take the function of this. Function of these means if I substitute these into x into y, we'll get the value of k2, that is 2 into 0.95 plus 3 divided by y, that is 4.015 minus 1 whole square. You will get the value, which this is equal to 3.015 whole square. Then we have 2 plus 0.915 plus 3 means 3.95 into 2. 2 into this term, that is equal to 2 into 0.95, that is equal to 5 2s are 10, 0, 1 carry, 9 2s are 18, 1 19, 9 1 carry, 2 0 0 1, that is 1.90. 1.90 plus 3 that is equal to 4.90, that is equal to 4.90. We have the term in the numerator, that is 4.90 divided by 3.015 whole square. If I do this operation, 3.015 into 3.015, I'll get the term 5 5s are 25, that is this term, 301 into 302 into 301, that gives me some value. Then I have to shift that by 3 into 3, that is 6 digits towards this side. I'll get some value. Let me solve it. That is 3.015 into 3.015. We have 5 5s are 25, 5 2 carry, 5 1s are 5, 7, 5 0s are 0, 5 3s are 15. Then we have 1 1s, 1 5s are 5, 1s are 1, 1 0s are 0, 1 3s are 3, 0, 3, 3 5s are 15, 5 1 carry, 3 1s are 3, 4, 3 0s are 0, 3 3s are 9. We have these terms here, that is 5, 12, 2, 10, 9, 0. That is 4.90 divided by 9.09 0225. We have these terms here. So if I simplify this, I'll get the value of this, that is f of this term, that has to be multiplied by 0.1, that is 4.90 divided by 9.090225. That has to be multiplied by 0.1, that is h. You will get the value of k2. Then k2 is used here with y0. What is the value of y0? That is 4. You will get the value of this y1, that is y1 equal to this. As a result of this, you will get the value of y0. What is the value of y0? Which is equal to 4. We have 4 plus k2 plus this term, that is 0.1 into 4.90 divided by 9.090225. We have these values here. So if you simplify this, you will get the value of y1. This is for Rungekutta second order method, RK second order method. Similarly, for y1 for is equal to y0 plus 1 by 6 into y0 y1 plus 2 times k1 plus 2 times k2 plus 2 times k3 plus k4. You will get this term. I am using the terms k1, k2, k3, k4. If that is the case, what is the value of k1? That is k1 is equal to h into f of x0 comma y0 comma, then k2 is equal to h into f of x0 plus h by 2 comma y0 plus k1 by 2. This is the formula for k2. Then k3 is equal to h into f of x0 plus h by 2 comma y0 plus k2 by 2. We have this term. Then k4 is equal to h into f of x0 plus h comma y0 plus k3. So you will get the values for k4. If you substitute these k1 values of k1, k2, k3, k4 into this equation, you will get the value of this y1 by adding that with y0. So that is the value we are going to use to find out the Rungekutta fourth order method. This is for second order method. This is for fourth order method. If you solve this, you will get the values like this. For the fourth order method, y of minus 0.9, you will get the values like this. Then for minus 0.8, you will get this. It gets decreasing. So observe it carefully. We have come to the value when the value of x equal to 0.0, we have the value of y which is equal to 3.46621270. Similarly, this is the value we have found using the Rungekutta fourth order method. So we have the numerical solution for this, that is 2x plus 3, that is 2x plus 3 divided by y minus 1 whole square, that is y dash is equal to this. This is the given equation for this ranging from 0 to 1, that is minus 1 to 1, that is minus 1 to 1 we have 0 here, minus 1 to 0 we have found another table, and 0 to 1 we have another table here. So with this I am concluding the session of the Rungekutta second order and fourth order method as a problem which is solved with the help of the formulas of Rungekutta second order as well as fourth order method. You can also do it for the trapezoidal method. Thank you very much. Thank you one and all.